Hey guys, welcome to today's lesson. Today we're looking at arithmetic progression. So we're moving on a little bit, I guess, from the two basic lessons that we've had. Just to recap, the first lesson we looked at, we introduced three S's, mainly the set, we looked at a sequence, and then we looked at a series. We know that set, we don't really need to know too much. The sequence we know was our collection of ordered terms or objects, whatever you want to call it, and then the series was the sum of the sequence. Now, in today's lesson, we're going to be focusing on sequences. Okay, so I think we used back then the example of 5, 7, and 9. So I'll use that for a little bit as well. And we're going to look at the arithmetic progression and I guess become a little bit more formal with our proof and our equations. Just first of all, I do want to distinguish the term arithmetic. I know it looks like arithmetic. I guess if I'm going back to I am an English teacher, so the word arithmetic, I believe, is a noun. So if you're doing arithmetic, it's an object, I guess. Whereas this arithmetic progression, it's describing the progression. Okay, so it's describing the progression, therefore no longer being a noun. I believe it is an adjective. But anyway, that's by the by. So an arithmetic progression, what makes it arithmetic? There are two types. I mentioned it last lesson. There's an arithmetic and there's a geometric. Okay, you can see in this progression we've got here, and it's a progression because it goes from smallest to biggest, so all sequences are progressions. We have got a constant value being added to it. Maybe better word, I guess, a constant difference. Okay, now we mentioned that in terms of it being a linear progression, okay, where the plus 2 was equivalent to the gradient. Okay, and we came up with that little term, that little rule, Tn equals 2n, that's the gradient, and then we added 3. Okay. What we'll be doing, as I said, looking at a bit more detail, we'll be using another formula that will better describe and better work with this situation. We also mentioned in that initial lesson that there were three types of sequences. Okay, three types of sequences. So I'm going to write them down here. We had the first one was our pattern, and that was something like, the first term, so 5, then 7, then 9. What I'm going to let the first term equal in this case, because remember I said to you, I want to come up with a bit more formalized versions of this. So the first term we're going to call it as A. And then the second term, we add on that difference. So let's call that A plus D. And this third term, we're going to have A plus 2D. The fourth term would be A plus 3D, etc., etc. Okay, where we know we have our first term. I might put this in a different color. We have our first term, our second term, our third term, and our fourth term. Okay, so that was more what our actual pattern was going to be. The next thing that we spoke about was looking at the formula. Okay, so coming up with that formula, which we use that formula there. But we're going to come up with a nicer way. Now, for our formula, Tn is equal to, let's look at this stuff here. You can see what is the common ingredient here. Well, a common ingredient, it's not the plus number that's going on, it's actually the A. Okay, that's that common thing that's going on there, that's the A. And then what's happening each time, you can see for the second term I've got 1D. For the third term I've got 2 Ds. For the fourth term I've got 3 Ds. So what I've actually got is 1 less than the number of terms, lots of Ds. Okay, now that's a slightly different formula than we used yesterday. We used like the nth term we used back in year 7, but this is the one that we're going to use for an arithmetic progression. Okay, that's going to help me to find the nth term, I guess. So if we used this situation, I think we said yesterday that T100, well, using that rule there, we can see it's 203. If I use this one, T100, we've got the 5 plus 99 lots of, and then the difference we said was going to be 2, okay, which makes, what's that going to be, 198 plus 5, which is 203. Kind of works out the same, right? It's just a different way of doing it, but it will make more sense to us as we go through, particularly when we get to our geometrics and certainly our sums. The third thing that we spoke about was that kind of one that I said wasn't really too important. Okay, that's what I'm going to do this in yellow. We kind of called the recursion. All right, and the recursion, we kind of said that if we know what that first term is going to be, then we knew that to find the term, we could find the 1 before it. So let's say tn minus 1, and we could add the difference on. Okay, so if we wanted to get 9, we could take the term before it. So 3 take away 2 is 3 take away 1 is the second term, which is 7. 7 take away 1, etc., etc. So 7 plus 2 is the 9. The reason why we do that is not for finding anything. I'll be honest with you. That's not really what we use it for. But we do get questions that ask us to test or to prove that something is, in this case, an arithmetic progression, or sometimes where it might be a geometric progression. Okay. So what we can do, we can kind of rearrange this, because if we want to know that there is a progression, right? Well, then what we want to know is that there is a common difference, which means if I sort of rearrange this, if I can take Tn, take away the term before it. In other words, 9 take away 7 is 2. 7 take away 5 is 2. We can see there's a common difference. We can't just do it once, because of course, what if you had something like 5, 7, and 20? It would work for that one, but it wouldn't work for that one. Therefore, that's not arithmetic. So what we actually have to prove in this case for all values of n, basically, that is T2 take away T1 is equal to T3 take away T2. And it's kind of what I just set up there with that example. I'll do that again just in case you kind of didn't get that. I set up for that example up here that if I said 9 take away 7 equals 2, I've taken 7 take away 5 equals 2, therefore they are equal. It's an AP. Okay, there is a common difference, it works. And most of our questions, we're only going to get 3 terms, okay, in a finite set, or even an infinite set. And so you only really have to prove the 2 of them, and that works out nicely. So realistically, the whole idea of recursion doesn't really matter to us. The 3 things that we need to be aware of, well, actually, I'm going to be honest with you, the 2 things that you need to be aware of and to be able to know how to do is pretty much going to be knowing your formula, okay, learning that, absolutely, and then being able to prove. Okay, they're the 2 things I want from you. Okay, so I'm going to stop right there. What I'm going to do, okay, so I'm a little bit mixed up there. I've got 2 pretty easy questions. Oh, sorry, I should say I've got 1 pretty easy question and 1 more challenging question. Have a quick crack at this. See how you get on. This is a pretty straightforward one, so you should be able to do it. It's pretty much the same question I gave you last time, but I'm giving it to you in a kind of different format. Okay, see how you go. All right, so how did you come up with? So find the first 3 terms and the 60th term when a equals 15 and d equals 3. So, well, the first part is they give you, okay, in this particular question, that a is equal to 15. We know a is our first term. We know that difference is 3, which means we're adding 3 each time, which means we've got 18 and 21. They're your 3 terms. That's not really hard, is it? Now, I want you to find the 60th term. So instead of using the nth term like we were using last lesson, we want to look at this formula. Okay, remember, a plus n minus 1d. And we want to substitute into it. Please make sure that you actually sub into it and show the marker exactly what you're doing. We want the 60th term. I don't care if you know it's 59. I want you to write 60 minus 1. Okay, please do me that favor. And we've got the times by 3. You can put the 3 at the front if you really wish. Now it's a matter of simply throwing that into our calculator. Okay, I prefer you do it in your calculator. And we come up with the answer of 192, which is our 60th term. Okay, it's pretty straightforward, but obviously it comes down to using that. all right? But I'm pretty sure it's on your formula sheet anyway, so there's no excuses. But then we come to example 2, slightly more challenging. Again, though, it's pretty similar, or kind of similar to the question I gave you yesterday, but obviously now you've got a new formula for the arithmetic progression, or the AP. You should be able to do this a little bit easier, hopefully. So show that 100, 92, and 84 is an AP. Okay, that's the first thing that we're being asked to do. We're being given a proof, okay, which means I want to be able to prove that there is a common difference. That's the whole idea. So if I'm trying to find a common difference, realistically, it's that recursion theory again. I'm trying to say that T3 take away T2 is equal to T2 take away T1. And realistically, guys, if you're showing that working out, that really shows the marker that you know exactly what you're doing, okay? Let's say T3 equals 84, take away 92, all right? And then we've got T2, so 92 take away 100. In either case, we get negative 8 equals negative 8. Therefore, yes, it's an AP. All right, because the common difference is the same, and that's a perfect way to write them out. If you want to do them separately and say T3 take away T2 is that equals negative 8, and then do the right hand side, up to you, left hand equals right hand, you know the rest. But the hard part, I guess, would be coming from this second part, which says to find the first negative term. Now, we spoke about that last lesson. We had a look at a very similar question. First of all, I'm going to write down our rule, A plus n minus 1d. Now, what we're looking at, we want this nth term, okay, whatever this is going to be. So, you know, if I throw a 1 in there, okay, for this particular question, we know what it's going to equal to. We want to find where this is going to equal to a negative number. In other words, what we want is this. We want to know when this is going to be less than 0. All right, so what we're actually doing is coming up with an inequality. Okay, our A, well, we can see that's clearly 100. Our N, take away 1D, well, we don't know what the N is, but we do know that the D is going to be negative 8, and it's less than 0. Okay, so what I can now do, it depends on what you want to do. I might actually expand the brackets. N times negative 8 is negative 8N. Negative 8 times negative 1 is positive 1. You can put negative 8 in front if that helps you. Okay, so it should be positive 8, sorry. And then we end up getting 108, take away 8n is less than 0. I can take the 108 to the right hand side, and then I'm going to divide by the negative 8, remembering though that we have an inequality, which means that when I divide or multiply by inequality, the sign will flip. So we end up having negative 108 over negative 8, which means basically 108 over 8, okay, which gives me n is greater than, I think it was something like 13.5 maybe, okay, which means my term has to be 14, because remember, I have to have a positive integer, okay. I can't have a negative term, doesn't work that way. We have first term, second term, third term, okay, counting numbers. Okie dokie. All right, so back to the question, find the first negative term. We haven't found it. We just know that it is the 14th term. So if I come back up into here, I might do it at the top because I've got a bit of space up here. I might do this in, let's say, kind of like pinkish. I'm going to say T14 is equal to, we know the A again was 100 plus, now we're doing 14 take away 1 times the negative 8. So equals, I'm going to throw that into my little calculator, and we get negative 4 as my answer, and that's it. Look, that's a relatively tough question at the moment. I really encourage you to grab out your textbook. I'm pretty sure it's exercise 7.14, and there are some pretty tough questions towards back end, particularly around questions 20 to 30. They're pretty tough, but I really encourage you to have a look at those questions, and then let me know if you have any problems. Have an awesome day, guys. I'll see you later on.